So just to give you an update, we've been working on our board. So this will be our first version. It's a 2-layer board, of course. We have LEDs and resistors for the LEDs. So let me enable the labels. So basically what I did was to put an LED on top of every text on the faceplate. Each of those labels or markings will have good backlighting. You have one resistor for every diode. That's to prevent the diode from burning out eventually. Like I've experienced that before without a resistor. It works for a while, but maybe a month later, the LEDs, or one by one, an LED will burn out till all the LEDs are totally burned and you don't have backlight anymore. I'm using like 100 ohm resistor for each diode, and when you select a diode, you have to make sure it's not pulling too much power, otherwise it could disable your Arduino. And it has happened to me, like I've designed some boards with that kind of problem. So it's mostly made of toggle switches, on, off, on. This would be an on, off, or rather for me, I used an on, on, so you can also trigger the off position if you want to. Over here I have a DIP switch that allows you to select the source of your backlighting. If you can see here, I have these pinouts, so there's a way for you to connect an external power source for your backlight. That's a good way of integrating your backlight throughout your panels, so whatever level will be controlled by one source using these connections. And if you're not using an external power, then it will use the power you supply on your Arduino, or you can put it in the off position, which is in the middle, which means there will be no backlight at all. Eventually I made provisions for an RX-TX connection because I'm hoping to enable interconnectivity between the panels that I make. That will reduce the need for more USB ports when running my panels. I've taken this design and sent it off for prototyping. So I had like 5 samples of these made. So the boards have arrived. Let's see. I should have like made the board myself for the prototype, but that could be a tedious thing to do, you know. If you know how to make a board, you know what I mean. So I'd rather just send it off and wait for it. I'd rather pay for that and be able to do something else while waiting. Yeah, so I have 5. At least if it works, then I already have 5 boards with me. You can make 5 panels and sell it off. There, nice. So let's build one. I order most of my parts from BGP. Not that I'm sponsored. I wish I was. No. So this is an on position. I mean on switch. So it's a dual position, which are both on. I could have used like an on-off switch, but then it's easier to like map them or program them because you have two buttons in effect, so you're not actually wasting the other button. While this is a 3 position: on, off, and on. For the laser switch, it's just on. I guess the best way to solder them is to use this as our jig. Yeah, so it fits well. I'll solder it, then I'll remove it from this. Becomes our jig then. And there we go. Now we remove it. Remove the board from the inner frame. Then I'll redesign the inner frame. With this approach, we're also assured that all the switches, like, they're all perfectly aligned, like there's no way it could have turned. And there we go. Remove it from the jig. So that becomes our jig now. There. So this actually goes all the way down there. Yep. Something like that. Yep. So let me add the momentary tactile switch. I need 2 of those. Fits just right. Perfect, see? So I'll just need to extend this. Maybe 3D print something that would extend that. And okay, now for the Arduino. I am almost out of Arduinos, so I should order soon. Cheaper when you buy them in bulk. Like when I buy them, I buy at least 10 of them. Makes it much cheaper. Yeah, maybe I should raise it a little. Yeah, so that's pin 9. Going to pin 9, pin 10, going to pin 10. You have the raw, going to raw. That's for the raw power. Boom. Okay, let's go ahead and solder everything else. You might also notice I'm using a thinner soldering lead. For small connections like this. That way we don't get a lot of excess soldering leads going all over, which could potentially cause a short circuit between two pads. But for headers like this, you need more solder because it's more solder because there's gonna be movement there, plugging and unplugging the connector. Okay, for now I guess that's all we have for today. Because I will need to make the modifications to my enclosure and my frame. So one is to get the lights to go through. Then take this out or move it so that it can accommodate the switch. Then do something about this. So for this switch, maybe have an extension. Then for this, we'll add the mounting, and then we'll cut out the port for the LED. We'll cut out the port for the USB and maybe another port for the connector, and maybe a hole for the dip switch, switching the backlight and or selecting